of A, again, but on the second calculation of the probability of A, you're restricting yourself to just looking at those that are in group B. So the probability of A, given that they have to be in B. If those probabilities stayed the same, then they're independent. And if they changed, then they're not fully independent. Okay? So the well, we'll see examples as we go through these. So a survey of 57 sixth graders was done to determine which subject was their favorite. So what do you think this is trying to see about? The relationship between gender and favorite subject. Do you think there's anything there? Do you think males are more likely to favor a certain subject? No? Or females? I would definitely think there's, well, I don't know if you think about careers like math, science careers are heavily dominated by males. Maybe not heavily, it's evening out over time, but versus English. Anyway, so there may be a gender thing going on here. Does it appear, based on the data, that the preference for math has dependence on a student's gender? So we're specifically looking at math. So we're going to calculate the probability of liking math, and then to see if it has independence or dependence from gender, we're also going to look at the probability of liking math given that you're a one gender or the other. So just pick one, female, just so we're all on the same page. So in both cases, we are comparing the probability of math. But one is math on its own. So what is the probability of liking math? What out of what? 18 math lovers out of 57 people, which is, give me a decimal, 32%. Okay? Now, if you're a female, and don't do this yet, but if you're a female, do you think the chances of math being your favorite would go up or down? What do you think? Do you know? Anybody? Any gut? All right. Well, if it changes at all, there's probably a relationship between gender and your favorite subject. So now let's calculate this probability. What is the probability of liking math given that you're a female? So we are totally restricted to our female category. So what is our denominator, Evan? 30 out of all the females. So out of 30, how many of those 30 like math? 8. And 8 out of 30 is 0.27. So something about being female caused a drop. Do you follow that? Something about being female caused a drop in the percentage of people of them that would like math. Okay, for the average human being, 32%. If you're a female, the probability of you liking math dropped. So there seems to be a correlation there. There seems to be, and you could argue cause and effect and correlation, but at the end of the day, all our purposes in Algebra 2 is to say these are not independent of each other. Not independent. Because in order to be totally independent of each other, the female portion would have no effect, and we would have gotten 0.32, and we would have gotten 0.32. Being a female wouldn't have changed the math probability. That's how you know they're independent, is if that probability hasn't been affected. One thing we are never allowed to say, supposedly, New York tells us, we're not allowed to say that they're necessarily dependent. We're only allowed to say that they're not independent. So don't ever write the word dependent. It's either independent or not independent. Go figure. That's just what they tell us. You would think not independent means you're dependent, right? It doesn't. Don't worry about it. Just don't ever write dependent. Okay, does it appear based on this data that the preference for social studies as a favorite subject has dependence on a student's gender? So we're going to look at the probability of social studies, and we're going to look at that probability of social studies given a certain gender. Let's keep with females. Who cares? One thing I do want you to notice, and this is something to take away really early on so you don't make this mistake, whatever you're calculating the probability of alone has to be the first one in your conditional probability over here. Do you follow? Stop crunching numbers. Listen to me. Do you follow? Whatever you're doing alone has to be what shows up first here. Yes? Probability of social studies, 19 out of 57. Probability of social studies given female. So we're still restricting ourselves to the 30 females. Out of those 30 females, how many like social studies? 10. So if you look at 19 out of 57, 33%. 10 out of 30, 33%. Those would be independent, because the likelihood of you liking social studies did not change based on your gender. So male, female, doesn't matter. Your chances of liking social studies are the same. Based on this sample, this isn't the whole world, right? This is just 57 kids. So is it conclusive? Is it end-all, be-all? Absolutely not, just based on this sample, okay? And that was actually another thing that they really let us know yesterday in general. With stats and probability, nothing's absolute, okay? Everything is based on just the sample that you took, or the hundreds of different samples you took. It's never a guarantee. It's never 100% certainty. Nathan. Is there a mistake on the chart? Oh yeah. That's silly. It should be 10. Good thing we weren't doing anything with the science column, because we would have had to go back and retest. All right. Okay. So this is the main test for independence. Probability of one, and compare it to the probability of that same one given a different condition. There is this other method, though, that we talked about very much so on the first day. I said that and probability, and means multiplication in math. So if you want the probability of A and B, then you take the probability of A and you multiply it by the probability of B. And that will give you the probability of both events happening. Assuming, though, that only works if your events are independent. So when we've used that so far, we haven't really been talking about independence, but I've only used that method in examples that I knew were already independent, because this only works if the events are independent. So on the flip side of it, we can use this to test for independence. If the probability of each event separately multiplied together gives you the probability of both, then you could say, then yes, it is independent. Okay, so it's another way of testing for independence, and depending on the way problems are worded, this might be the method. There's the conditional probability way up here, and then there's this method. So this example says the probability that a person is left-handed, the probability of being left-handed is 0.12. The probability that they have brown eyes is 0.42. And the probability that they have brown eyes and are left-handed, so really that's the probability of left and brown eyes, is 2%. So are these independent? So you would just check. Is our and probability are 0.02, does that equal the 0.12 times the 0.42? So if you do that, you'll get 0.02 equals 0.0504. Are they equal? No. So is the event independent? No. Support your answer. Your work supporting the answer. So they're not independent. Interesting. So your left-handed versus right-handed. Maybe somewhere down the line, redheads are less likely to be left-handed or something. Some small, how big or how small the correlation might be, who knows? But interesting. In 4 and 5, assuming that they're independent events, find the probability of Q and R. So since they are independent events, when I see and, I can do multiplication. So the probability of Q and R, since they're independent, will be equal to the probability of Q times the probability of R. The probability of Q is 1/8 times the probability of R is 2/5. So this one gives us 2/40, which is 0.05. And the second example, same thing. It's just rather than giving you fractional probabilities, it's giving you decimal probabilities. So the probability of Q is 0.8 times the probability of R is 0.2. 0.8 times 0.2 is 0.16. Okay, so if you know they're independent and you're given and probability, you can just multiply it. All right, suppose you have you have 7 CDs in a box. 4 are rock, 1 jazz, 2 country. How about those CDs that you own, huh? How many CDs do you own? I could bring you in my summer '99 CD mix. We could let Mrs. Grzanti and I could jam out to that tomorrow. Yeah, maybe we'll bring it in on Monday after break just for fun. I'll have it playing as you roll in. Okay. All right. Today you're choosing 1 CD without looking. You're going to play it, and then you're going to put it back in the box. Tomorrow you're going to do the same thing. Now, let's think conceptually about this, because we have talked conceptually about independent. If I pull a CD out, that's my first event. I'm going to put it back in. So, and then reshuffle up the CDs, and then tomorrow I'm going to do the same thing. Is whatever CD I pick today going to affect whatever CD I pick tomorrow? No, totally independent, because I've returned the CD back into the box. I've returned, so everything tomorrow has the exact same probability as it did today. So these I know just from that. They're not going to tell me they're independent events, but I need to make sure, are they independent events before I can go ahead and find the probability of choosing country on both days. So the probability of country and country. The probability of picking country the first day is 2 out of 7. And means multiplication, because I've already confirmed these are independent events. And my probability of choosing country the second day, 2 out of 7. So I get 4 out of 49. Good? Number 7, there's a 50% chance of thunderstorms on Monday, 50% chance on Tuesday, and a 50% chance on Wednesday. Assume these are independent events. What is the probability that there will be thunderstorms on Monday, Tuesday, and Wednesday? Probability of thunderstorm on Monday, and on Tuesday, and on Wednesday. So on Monday it's 0.50, times on Tuesday it's 0.50, times on Wednesday it's 0.50. So just really hitting home the fact that and probability means multiply as long as we know the events are independent of each other. Okay? Otherwise we'd have to find a different way. So 0.125. Let's look at this spinner one. Probability of getting an even. What do you think, Aiden? 1/2. Very good. 4 out of 8. Probability of getting an even given that the outcome was prime. So we have to be prime. Which of those numbers are prime, Connor? Hmm? 2, 3, 5, and 7. So, what does our fraction look like? The probability of being even given that we're dealing with a prime number. Well, 1/4. There's 4 prime numbers. Of those 4 prime numbers, how many are even? 1. So, look at these. Probability of even compared with probability of even given prime. Is being even independent from being prime? Are these independent of each other? Or was there something about being prime that caused your probability to drop? Right? The second is true. Something about being prime made me less likely to be an even number, because an even from the get-go was 50% chance. Once you know you're a prime number, your chances of being even drop significantly, right? We know that because if you're an even number, you're always going to be divisible by 2. So even numbers are almost never prime. The only even number that is prime in this world is 2. And that's just because it's too small to have any other factors. So these are not independent. Being prime is what makes you less likely to be an even number. What about probability of being even given that you're less than 5? So how many numbers are less than 5 on our board? 4 of them. 4, 3, 2, and 1. So out of those 4, how many are even? 2 out of 4. So let's compare the probability of being even, which was 50%, and now the probability of being even given that you were less than 5. Was the fact that you were less than 5 making you more or less likely to be even? No. They both were 50%. So these two, being even and being less than 5, are completely independent events. Nothing about being less than 5 makes you any more or less likely to be even. Okay, the last thing I want you to do that you picked up on the way in was this little entry. So take a minute for bonus points. A couple minutes, and I'll come around and look if you have answers. And there are 2 probabilities I'm looking for. What is the probability that a student participates in both sports and music? And what is the probability that a student participates in neither? So I'm looking for 2 probabilities by the time you're done. Probability of both, probability of neither. And if you get them both right, you'll get double bonus points. If you get one of them right, you'll get some bonus point. And then if you get none, you get none. While you're doing that, I'm going to pass out your homework. Oh, okay. And the answer there is 325. So that was 325. If you know Z, what was 325? 433. Go back and get Y, which is 108. And then if you know Y is 108, what plus 108 is 649, 541. Now on top of that, you need your neither. 1376 student total minus all of these will tell you how many are in neither, which was 402. So your probability of both is 150.